Bismillahirrahmanirrahim. Mohamed Saeed with you, physics teacher. We are going to solve the Moasser questions, Unit 1, Chapter 1, Electrical Current and Ohm's Law. Lesson number 1. For third secondary stage, question number 1. Write down the scientific term for each statement of the following. Number 1. A flow of electric charges through conducting material, electric current. Number 2. The quantity of electricity passing through a cross-section of a conductor in 1 second, electric current intensity. Okay, number 3. The electric current intensity due to the flow of a quantity of electricity of 1 coulomb through the cross section of a conductor in 1 second. We have two units, 1 coulomb and in 1 second. So we should write the measuring unit of the first physical quantity, the electric current intensity, so ampere. Number 4. The quantity of electric charge that when passed through a cross section of a conductor in 1 second, it produces electric current of 1 ampere coulomb. Okay, number 5. The work done to transfer a quantity of charge of 1 coulomb from point to another. Electric potential difference. Number 6. The potential difference between two ends of a conductor when a work of 1 joule is done to transfer unit charge between them, volt. Number 7. The position of the flow of the electric current when it passes in a conductor. Also, it is the ratio between the potential difference between the two ends of a conductor and the electric current intensity passing through it, electric resistance. Okay, 8. The electric current intensity passing in a conductor at a certain temperature is directly proportional to the potential difference between its terminals, Ohm's law. 9. The resistance of a conductor that permits the flow of a current intensity of 1 ampere when the potential difference between its ends is 1 volt. We have two measuring units, so we should write the measurement of the first physical quantity, the resistance, so ohm. The measuring unit of resistance is ohm. Number 10. The resistance of a conductor of length 1 meter and its cross-section area 1 meter square. Resistivity, electric resistivity. Also, it has another definition, the reciprocal. Reciprocal means 1 over reciprocal of the electric conductivity, 1 over sigma, which means the reciprocal of electric conductivity of a conductor. Also, it has another definition, the resistance between opposite faces of a unit cube of material. Resistivity, electric resistivity. 11. The reciprocal of the resistivity of the conductor. Reciprocal of resistivity 1 over rho E, which means conductivity, electric conductivity. Electric conductivity. Question number 2. Choose the correct answer. Number 2. Choose the correct answer. Number 1. The equivalent unit to coulomb per second is coulomb per second, which means Q over T. Q over T equals I. So Coulomb per second equivalent to ampere. So the true answer B, ampere. Okay, question number 2. If the length of a copper wire is doubled, L2 equals 2L, and its cross-section area is decreased to its half, A2 equals half A. Then its resistance, R2 equals what? Okay, R equals rho E L over A. In this case, the wire doesn't change, so rho E in first case equals rho E in the second case. So we start from this information, rho E equals rho E. Rho E1, which equals R1A1 over L1 equals R2A2 over L2. Okay, R1A1 L1 equals R2 A2 equals what? Half A1, and L2 equals what? 2 L1. A1 cancel with L1, sorry, A1 with A1, L1 with L1, so R1 equals R2 over 4. So R2 equals 4R1, which means that then its resistance increases 4 times. The true answer is C. The resistance increases 4 times. Okay, question number 3. A conductor of regular cross section, its length 20 meters, L equals 20 meters, and its resistance 108 ohm. And another conductor of the same material, so rho E in this case equals rho E of the other wire, because they are made of the same material. Its length 5 meters, L1 R1, L2 of the second wire equals 5 meters, and its cross section area is 3 times A2, 3 times that of the first conductor, 3 times A1. Then the resistance of the second conductor, R2 equals what? Okay, we start from this information, rho E of the first conductor equals rho E of the second conductor, because they are made of the same material. He told me that. And another conductor of the same material, so rho E of the first conductor equals rho E of the second conductor. Rho equals what? Rho E equals R1 A1 over L1 equals R2 A2 over L2. Substitute R1 108 times A1 over L1 20 equals, on the other hand, R2 times A2 3A1, so we can cancel A1 with A1 over L2 5. So now we can get R2 5 times 108 over 3 times 20. R2 equals 5 times 108 over 3 times 20. Okay, 5 times 108 over 3 times 20. So 3 times 20 equals 9. So R2 equals 9 ohm. The true answer is C, 9 ohm. Okay, the next question. Okay, question number 4. Question number 4. If a wire is stretched till its length is increased by 50%. So R1 equals 1. The new length L2 increased by 50%, which means that it increased 1.5 of R, sorry, L1. L2 equals 1.5 L1 because it increased by 50%. The first length, for example, 100 centimeter, the new length increased by 50% of its magnitude. So if it is 100, so the new length 150. So L2 over L1 equals what? L2 over L1 equals 150, for example, over 100, which means what? 1.5. L2 equals 1.5 L1. Okay? From its original length, its resistance will increase by what? R2 will increase by what? Increase by what? Not R2 itself. We want to calculate the increase in resistance, not the resistance itself. We want to calculate the increase in resistance in the second case, not the resistance itself. So we should get the second resistance and then we calculate the increase in resistance. Okay. When a wire is stretched, its volume doesn't change. So volume in first case equals volume in second case. Volume equals what? A1 L1 cross section area in first case times L1 equals A2 L2. A1 L1 equals A2 L2 equals what? Times 1.5. We replace L2 by 1.5 L1. L1 cancelled with L1, so A1 equals what? 1.5 A2. Okay. Also, the resistivity of the first case equals resistivity in the second case because the type of or the kind of the wire doesn't change. It is the same type of material. So rho E in the first case equals rho E in second case. Rho E in first case equals rho E in second case. Rho E equals what? R A over L. R1 A1 over L1 equals R2 A2 over L2. In this case, R1 A1, we replace A1 by 1.5 A2 times 1.5 A2 over L1 equals R2 A2 over L2, replace L2 by 1.5 L1. L1 cancel with L1, A2 cancel with A2, so R1 times 1.5 R1 equals R2 over 1.5. So R2 equals 1.5 times 1.5 R1. 1.5 times 1.5 R1. 1.5 times 1.5 equals 9 over 4. So R2 equals 9 over 4 R1. So the increase in resistance equals 9 over 4 minus 1. We can, or 9 minus 4, 9 over 4 minus 4 over 4 equals what? 5 over 4. So the increase in resistance equals 5 over 4. The true answer is C, 5 over 4. Okay, question number 5. Says that the product of resistivity and conductivity, rho E times sigma, equals what? We have learned before rho E equals reciprocal of conductivity. So rho E times sigma equals 1. Rho E times sigma equals 1. For the same material, space 1 equals 1. C, the true answer, C equals 1. Okay, question number 6. When the length of a wire decreases to half, so L2 equals half L1, and its radius increases to double. Its radius R2 equals to R1. The conductivity of the material. There are two only factors that affect the conductivity or resistivity. Number one, the type of material. Number two, the temperature. So in this case, type of material doesn't change, and also temperature remains constant. So the conductivity remains constant or remains unchanged. So the true answer is C, remains unchanged. Okay, 7. Which of the following figures represent the relation between the conductivity of the material of a conductor and its cross-section area? We said that conductivity, also resistivity, depends only on the type of material and temperature. There are only two factors that affect the conductivity and resistivity. Conductivity, also resistivity, depend on number one, type of material, number two, temperature. These are the only two factors affecting conductivity and resistivity. Temperature. Any other thing doesn't affect them. So in this case, conductivity and area, we said that area doesn't change conductivity or resistivity. So this is wrong. Also in this case is wrong. Also wrong. So the true answer is D, because by changing area, conductivity or resistivity doesn't change, remains constant. The only factor that changes conductivity or resistivity, temperature of heat, temperature in this case, temperature, so conductivity decreases. If we write temperature and here conductivity, so by increasing temperature, conductivity decreases. If we write type of materials, so we have another, for example, iron, copper, aluminium, and so on. So each one has different resistivity or conductivity. These are the two only factors that affect conductivity or resistivity. Any other thing except these two factors doesn't change conductivity. So the true answer is D, conductivity or resistivity. With area, with length, with what else? Area, length, radius, conductivity remains constant. So the true answer is D. Okay. 8. A conductor of radius or length L and resistivity rho E has a resistance R. If it is stretched till its radius is decreased to its half, R2 equals half R1, what is the new resistance? R2 equals what? Okay, we said that volume doesn't change. Volume 1 equals volume 2. Volume equals what? A1 L1 equals A2 L2. A1 equals what? By R square, by R1 square. L1 equals by R2 square L2. By cancel with by. R2 equals what? R1 square L1 equals R2 square equals 1 over 2 R1 all power 2 L2. So R1 square L1 equals 1 over 4 R1 square L2. R1 square cancel with R1 square. So L2 equals what? 4L1. L2 equals 4L1. So rho E, because the material of the conductor doesn't change. So rho E1 equals rho E2 in the first case and second case. Rho A equals what? R1 A1 over L1 equals R2 A2 over L2. Substitute R1 equals R, R1 equals R, A1 equals what? A1 equals by R1 square over L1 equals on the other hand R2 A2 by R2 square, and R2 square equals half R1 all power 2, half R1 all power 2 over L2. L2 equals 4L1, 4L1. L1 cancel with L1, by cancel with by. So R1 square equals R2 1 over 4 R1 square. R1 square cancel with R1 square. So R2 equals what? 4R1. 4R. 4R. So the true answer is B. 4R. Okay. Question number 9. Two conductors made of the same material. So rho E1 equals rho E2. Of the same material are connected across the same potential difference. V1 equals V2. Conductor A has twice the diameter and twice the length. Conductor A has twice the diameter, so which means twice the radius. RA equals to RB, and twice the length. LA also equals to LB. What is the ratio of the power delivered to A to the power delivered to B? Power A over power B equals what? Two conductors made of the same material, one connected across the same potential difference. The same wire A and wire B. A and B. Same potential difference. So VA equals VB. Okay. What is the ratio of the power delivered to A to the power delivered to B? Okay, VA equals VB. RA and RP. We have learned that rho E1 equals rho E2. Rho E equals rho E. So rho E equals R A of A over LA equals RB AB over LB. Substitute. RA A of the A equals by RA square over LA equals 2LB equals RB AB by RB, and RA we can replace RA with 2RB, RA to RB, okay. RB square over LB cancel with LB, by cancel with by, RA square we can replace RA with 2RB, 2RB all power 2, 4RB square over 2 equals RB square over 1. RB square cancel with RB square. So RA equals to RB. RA equals to RB. Power equals what? A lot of laws. IV or VI, I square R, V square over R, because we have V and R. So power of wire A over power of wire P, consumed in wire P, equals VA square over RA over times RP over VB all power 2. Replace VA equals VB. They have the same potential difference, so we cancel VA over VB. RB equals what? RB over RA. We can replace RA with 2RB. 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 RB cancels with RB. So the ratio B power consumed in wire A to the power delivered to B equals 1 over 2. 1 over 2, 0.5. The true answer is 0.5. Another question, number 10. Question number 10. A, B, and C are three copper wires. A, B, and C are three copper wires. So rho A equals rho B equals rho C. Rho A equals rho B equals rho C, because they are made of the same substance, copper. Have the same length but differ in diameter. LA equals LP equals LC. But differ in diameters DA, DB, and DC, which means they differ in radius. Each one has a certain radius. At certain temperature with resistance RA, RB, and RC respectively. The opposite graph shows the relation between the current passing through each wire, and the potential difference across its terminals, and potential difference. Which of the following is true? Okay, we should get the slope. Slope equals what? Slope equals y over x, I over v. I over v. What's meant by I over v? Reciprocal of r. 1 over r. Which means that the greater slope has the lowest resistance. The greater slope RA less than RB less than RC, because slope equals reciprocal of resistance, which means by increasing slope, resistance decreases. So RA is lower than RB, lower than RC. So resistance of RA, they have the same length. R equals what? Rho E L over A. Rho E of the three substances is the same, also length is the same. So the relation between RA and A is inversely proportional. A equals by R square. So the relation between A and radius is directly proportional. So we can say R directly proportional to diameter. RC has the greatest resistance. So inverse proportional to the diameter. R and A inverse proportional. So RC has the greatest resistance. So it has diameter of C is lowest. Lower than DB, lower than DA. DC lower than DC, lower than DB, lower than DA. Diameter of A is greater than diameter B, so the true answer is B. DA greater than DB greater than DC. True answer is B. Okay, 11. If a wire is stretched so that its length increased to the double. Wire stretched, so volume in the first case equals volume in the second case. Its length increased to the double. L2 equals 2L1 of its original length. Then its resistance increases to what? R2 in the second case equals base R1. Okay, we have learned that the wire made of the same material, so rho E in the first case equals rho E in the second case. Volume 1 equals volume in second case. Volume equals A1 L1 equals A2 L2. Okay, A1 L1 equals A2 L2 replaced by 2 L1. So L1 cancel with L1, so A1 equals 2A2. Rho E equals rho E. So rho E equals what? R A over L, R1 A1 over L1 equals R2 A2 over L2. R1 A1, we can replace A1 by 2A2, 2A2 over L1 equals R2 A2 over L2. We can replace L2 by 2L1, 2L1. L1 cancel with L1, A2 cancel with A2. So 2R1 equals R2 over 2. So R2 equals 4R1. R2 equals 4R1. So resistance increases 4 times. 4 times. The true answer is C, increases 4 times. Okay, 12. Two wires are of the same length. Two wires of the same length. L1 equals L2. And resistance R1 equals R2. But one of them is copper and the other is iron. So rho E1 is not equal rho E2. So the ratio R iron, I means iron, to R copper equals what? Okay. R1 equals R2. R1 equals R2. Okay, R1 equals what? Rho E L iron. We can say R iron equals R copper. Rho E iron L iron over A iron equals rho E copper L copper over A copper. So rho E iron L iron equals L copper. So we can cancel L iron with L copper over A iron. A equals what? By R iron bar 2 equals rho E copper over A copper by R copper bar 2. By cancel with by. So RE RI bar 2 over RC copper bar 2 equals rho E iron over rho E copper square root for the both sides. So RI or I iron over I copper equals square root rho E iron over rho E copper. So the true answer, square root D square root rho E iron to square root D is the true answer. Square root rho E iron to square root rho E copper. Okay, what's meant by